I'm writing a Minecraft server entirely from scratch in Rust, and over the last month I have made it multi-dimensional. Yeah, Minecraft is of course already 3D, but yeah, let me show you what I mean here real quick. Now we can light the nether portal, and now we're in the nether. Oh my god. We can even go back, and then we can just walk over here to my neat little end portal and also go to the end. And yeah, now we're here. There's no real like dragon fight or anything like that yet. Yeah, it is kind of just yeah, he's just licking the ground. Don't worry about it. So let's just leave him be real quick. A lot of things were of course necessary to get to this point, so let's take a look behind the scenes at the code. So one of the first things that I had to do was to get rid of a lot of like hard-coded reference to the overworld dimension. So as you can see here, I often just well, retrieve the overworld dimension wherever, and it worked perfectly fine when that was only the overworld. But yeah, now I had to kind of replace that with, well, the actual dimension, obviously. So for that to work, I'm now, of course, keeping track of the dimension actually in the player struct, which is something that I didn't do before, which, yeah, was kind of necessary to make this all work, obviously. And then to actually change the dimension of the player, there's also this neat little new function here, which just, well, overrides some stuff and positions and then sends the player the respawn packet, which is actually kind of the way that you tell the player that it's now in a new dimension, which is kind of interesting because that's also the same packet that you would use when the player dies and then is supposed to respawn. And then setting the new position will also just send the player the new chunks around it. Yeah, and then we also need to do things like spawning in the entity for other players, I think. And, well, just setting some things up again because it's basically like the player respawn just now in a new place. And if you kind of think about it, if you die and you go to hell, then you basically just respawn in hell, right? So, I mean, yeah, makes a ton of sense. Then I, of course, also had to do changes to the actual world. Well, not that many changes actually, because the world already had a hash map of dimensions before that then only ever contained the overworld. Now during world loading and saving, however, there are some changes. So now instead of just loading in the overworld, I'm also, of course, now loading the nether and the end. And then when saving, I will also go through all the dimensions and save all of them to disk. Now that also means that I had to do some changes to the actual like loading from disk functionality, of course. So now new here is the dimension name that we have to give this function. Now, since a couple of Minecraft versions, the number of chunk sections in a dimension also depends on the dimension. So for now, I've just hard-coded that the overworld has 24, while, well, the rest has 16. It's not ideal to hard-code this, and in the future, when I add support for custom dimensions, I will, yeah, do this, like, properly, basically. Because you could also theoretically have only 16 in the overworld, and whatever. Now I can also no longer hard code where the region files are stored because, well, that also of course depends on the dimension. And I've now used this opportunity to already update that part of my server to 26.1 if you want to call it like that. So now, as you can see over here, the world is now, well, looking a little bit different. Before then, in like older Minecraft versions, you had the overworld stored directly in the world directory, and then you had this like dim1 and dim-1 folder for your nether and end. But now they've reorganized things a little bit. So now you have this dimensions directory, and underneath there you have the overworld and a nether with a proper name, and they contain then their like region files and entities and all that good stuff. Now I didn't do anything to deal with existing worlds, so yeah, that will now after updating just no longer work. So you just have to manually move some things around, but I think that's fine for the moment. And then the rest of my world loading code is like pretty much the same because, well, the region files and the chunks within them, that's all pretty much, as I said, the same between the different dimensions. This is now the commit in which I've changed the world storage format. So as you can see, the player data is now stored in a slightly different place. I had to do some changes to here apparently a right level Dutch thing. Yeah, we're now building together, as I said, the path a little bit differently for where the region files are stored. So in the end, that wasn't actually too much stuff to change. And then for testing purposes, I just added this new dimension command that I already have shown you a little bit earlier. This is just a very simple command that lets you just change the dimension, and as an argument, you give it a new dimension. And then it will just, get your player default spawn dimension and just call your player.change dimension function that we also already looked at a little bit earlier. So just implementing this part was pretty easy, and then I decided it's time for the nether portal. Now, nether portals are kind of funny because they can come in like different shapes and sizes, and you need to basically just make sure that you you don't have anything within them that is not air, and they have to also be obsidian all around and not some random dirt block somewhere. And then you need to also be able to light them from any block. Yeah, it's a little bit involved, and that's of course not even to speak about that you can break them completely like that. Yeah, that was quite a little bit of work. So let's just kind of look at the code there real quick. So this is handled basically through my like special block functions. Let's just call them like that. So first we have the one for the fire block type. And for this, I've implemented the get block state ID functions. Usually I would use this to determine which block state a block should be placed in. So for example, if we have a fence right here, this is the default state, but when you place a fence next to it, they should connect. So this is now a different block state than that one, then that one. And yeah, these functions are then just used to kind of calculate or figure out which special block state a block should be placed in. And yeah, I mean, I'm placing nether portal blocks here technically, but this all originates from a fire block. So the first thing I'm doing right here is just trying to figure out which block position I have to look at to like figure out if this fire was even placed on obsidian. And yeah, that's of course dependent on the block face. So this is just comes like straight from the packet from the client. So for example, if it's 0, then we have to look at like one block above it, and if it's 1, then we have to look underneath it, and so on and so forth. And then we can just grab that block from the dimension, and then we can just check if this is like actually obsidian. Now, if it is obsidian, then we have to do a little bit of magic right here with the get portal block positions function. So in here, I'm basically just trying to figure out if this is a valid portal or not, and if it is, then in which block positions I have to place the actual portal blocks. So my first idea was to just basically just look at the block that I placed the fire on, and then we look to the left, to the right, and then up, and then around, and just kind of try and snake around and check if like there's an obsidian block there, and there, and there, and there, and if it's not there, then if it's there. Yeah, I quickly realized that is extremely annoying and would be a ton of code, and yeah, then I still just know that there's like an obsidian frame around it and not like how big it is, if it's too big, if it's too small, if there are any blocks inside of here. So what I'm now doing basically instead is just looking at the air. So if I like place my fire block right here, I'm just looking to the left and the right and see like how many unobstructed air blocks there are, and then also up and down, and how many air blocks there are. And then if it's within the like size limits of another portal, I can then just quite easily, of course, get the full rectangle of air. Then I can check if it's all air or if there are any like stray blocks inside of there. And then also just checking the outside perimeter, and if those are all obsidian blocks is also then relatively straightforward. So yeah, here I'm just starting with the Y direction, so up and down, and trying to find like all the air blocks in that direction, which is then just going from 1 to 23 in each direction depending on the starting position and the direction that we're going. And yeah, then I'm always just checking, like, is this an air block? And if it is, then we go to the next block and check if this is an air block, and so on and so forth. And once we've reached a block that is not an air block, then we can just return the whole number of blocks. So then we know how many blocks are in the y positive direction, how many in the negative direction. And if that is between 2 and 23, then we can move on. Otherwise, we just return, well, an empty vector, so basically there are no valid portal blocks to place. And then we're just doing the same for the x direction. So there should be at least one. I think I have maybe... Yeah, I think I've tested this. This needs to be one or more. I mean, it's 0 for the 0th and then 1. Yeah, I think this makes sense. Of course, if there are not enough blocks in the x direction, then we can also check the z direction, because of course you can place portals in the two different directions. Yeah, and then here we're just, I think, checking if the like outside perimeter is all obsidian. Then back in like the main function, we then just get all the portal blocks, and then if we actually got some portal blocks, then we go through all of them, check that they are air. And if there are, then we are just pushing all the portal blocks into the output. So we are then just, well, placing them all basically. And like that is roughly how I place all the portal blocks inside of the portal when it's valid portal, obviously only. Now breaking the entire portal is also kind of interesting. So for that we don't have to use the fire functionality stuff. We instead go to the... Where is it? Instead we go to the nether portal, of course. So in here we only have the blocks update function. Now the update function basically just gets run when blocks around this block change. So if we break the center portal block, then the update function of the surrounding portal blocks would then be run. And here we basically just check or get all the surrounding portal blocks. Again, depending on if the portal is in the x or in the z axis. We get the obsidian and the different portal block states ID, and then we go through all of them and check basically like if the surrounding blocks are either still nether portal or obsidian, and if they are not, then we just remove that nether portal block, which will then also trigger the update for the surrounding blocks. So yeah, well, basically if I would now hit this block, we check, is this still a nether portal? Is this still a nether portal? Is this still a nether portal? Wait, no. If I break this block, then the update function for this, and this block gets run. Then they would see that, well, they're not just portals in all directions. There's actually an air block right here. So that means that this block right here, for example, would then need to be removed, which would then run the update function for this and this and this block, which would then again realize that there's air next to them, which would then break this block and then run the rest of the update functions there basically. So just like that, the entire portal is then gone. So now we can just go through the portal and everything works perfectly, right? Well, not quite. We still then have to do like the actual logic to check if the player stepped into the portal and all that good stuff. So this then happens in the player's tick function. So somewhere deep inside of it, we have this little check here to see if the player's location has changed in the current tick, because we don't have to, well, run the portal logic every tick if the player just standing still, of course. We convert the position then to a block position, and then we just check if at any of the blocks that the player occupies there is a portal block, which we would do right here if any of those blocks are another portal block. Then we change teleport to true, which would then set the portal cooldown to 20 ticks, which basically just means that the player doesn't get teleported back immediately when they step through a portal. This gives just a little cooldown. And then to the entity tick outcomes, we just push this use nether portal enum variant basically. This is because, well, the entity's tick functions, they don't do really a lot of stuff immediately. They just check and figure out a bunch of stuff, and then at the end of the entity's tick cycle, I'm then applying all the necessary changes, which makes certain things a little bit easier. So now the player has stepped into the nether portal, and then we just say the new dimension is either the nether if the player is currently in the overworld, or the overworld if the player is not. So then here is where this entity tick outcome then gets handled, but not a lot of stuff is actually happening here. The problem is basically that within this like processing of the entity tick outcomes, I can only look at the dimension that the entity was originally in. Now that the player is changing the dimension, things do get a little bit more complicated. So I've basically built a new kind of task system that just runs or has access to all the dimensions. This way, most of the entity tick stuff can run independently per dimension. So in the future, I can just spread this out over multiple threads, so things can just run in parallel and are a little bit faster. But for like certain things where you need access to all the dimensions, we can then just do that in a separate kind of task queue. And in here right now, I pretty much only have like player uses the nether portal or the end portal as functionality, basically. So we grab the player, we grab then the new dimension. We do a little bit of math here to figure out where in the nether dimension or the overworld the player should go. That's just, because just in case you are not aware, the scale of the coordinate system basically in the nether is quite different from the overworld. So for every block that you travel in the nether, you should travel 8 blocks in the overworld. So here we do that kind of math to convert that. And then I'm basically just doing a little bit of kind of stupid brute force logic right here to find any nether portals that are nearby in the target dimension. So we're looking at kind of a 64 by 64 square around the player and trying to find a nether portal block in that sort of range. So there we just try to find basically the closest nether portal that exists in the other dimension. So this is not really that ideal because of course we are looking at like 64 by 64 by 256 blocks. So that's kind of just generally a lot of blocks to look at basically. Yeah, in the future I'm thinking about maybe having kind of a central registry of all the nether portals, so I don't have to look at like thousands of blocks basically every time someone steps in the nether portal. Still, for now the performance overhead of this is not that problematic, I think, because, well, this doesn't run every tick, right? Like how often does someone actually go through nether portal? So maybe the like simple and stupid solution is just better for now, but yeah, as I said, in the future when performance becomes more of a consideration, this is certainly something that needs fixing. So you basically just check, hey, is in kind of this huge range of blocks, is there an existing nether portal? And if there is, then we can just teleport the player there basically. So we can just call this player change dimension function again with that portal location. Now, if there is not, then we need to, of course, create a new nether portal. At this point, vanilla Minecraft would then kind of try and find a good place for that portal to like put it. If you've ever played Minecraft and gone to the nether, you've probably realized that you are not just placed into like the center of a wall or something. It tries to kind of put you on the ground somewhere nice, and if it can't, it just spawns a new portal somewhere in the air. I've decided to again take a little shortcut here and just always just spawn the portal at kind of the exact coordinates from the conversion that I've done earlier. And then we're just creating all the blocks basically, so a lot of obsidian blocks and the nether portal blocks. I'm not creating any like air blocks somewhere, so you could get actually kind of stuck, I'm now realizing. So yeah, this will be again something for improving in the future maybe. But then I'm just creating all of those blocks and I'm changing the player's position to, or the dimension with that new position where I've just placed that nether portal. And I think that's all I've done about the nether portals. Now, end portals are also, of course, very, very important. So as you've seen earlier, we can now light up a portal. For that, we, of course, need to then check every time you put an Eye of Ender into nether portal frame, if like all the other nether portal frames around it are correctly there with the right orientation and everything. And then we can just place all the nether portal blocks in the center. For that again, I'm using those block functions. This time, of course, for the end portal frame. And this is getting a little bit more stupid maybe. For the end portal frames, I could hard code things a little bit more, basically, because end portals are always the same size, always the same shape. They are relatively simple in that regard, so unlike nether portals that can come in various different shapes and forms and sizes, they are, as I said, relatively simple. So this time it's the interact function. So now when the player is interacting with a nether portal, an end portal frame, we first just check if the player has an Eye of Ender in their hand. If not, then we just do nothing. And also if the end portal already has an eye in it, we also do nothing. But now if the player is in survival mode or adventure mode, I'm actually not quite sure. Can you light an end portal in adventure mode? Maybe. I don't know. But if they do, then we decrease their count of like the ender eyes in the inventory by 1. And then we just check. First we get a couple of nether portal IDs, and for like depending on which way they're framing and if they have an ender eye in them, and then we just basically check like, hey, the block that we interacted with, like what way or what coordinate or what direction, cardinal direction was it facing, right? And then things do get a little bit convoluted. Basically what I'm doing is I'm checking, okay, oops, I did not want to do that. So basically what I'm then doing is we're looking at, why am I always doing this? Okay, so then what I'm basically doing is looking, okay, if this is a north facing portal, then we just check, okay, is the left or is the right also an eye? And yeah, we can reuse or make it a little bit easier by just having then an offset for blocks to check. So if it's the center one, we don't have an offset. If it's the right one, and we can just move everything in the x coordinate to like -1, so we check again from this block. Or if you're here, we are moving it in the plus x direction by 1, so we're still checking from here. Then we can just check like, hey, is like z -1, -2, -3, are these all empty? No, we're not checking the end portals, we're checking only the frames, of course. So we can go like 4 in the negative direction, check, hey, is this like an end portal frame facing in south with an eye in it? And then also like +1 in the x direction, -1 in the x direction. We can check all of these, we can check all of these. And the same logic then just kind of copy paste it for all the different directions. And that is just what we're essentially just doing here. So we are checking, right, if the +1 and the -1 is both a north and a filled portal ID, then the offset is 0. If +1 and +2 is filled, then this is then an offset of 1. If it's -1 and -2, then the offset is also -1. And then we just check, is x +2 plus the offset and z minus, is that west filled? Is like x +2 plus the offset z -2, then still a west filled portal? Yeah. This is just a lot of code, and then all the blocks to all right, then these are all the end portal blocks that we then place. Then like x -1 plus the offset and z -1 and x plus the offset and z -1 and all these. And then this is the same for like the east and the south, and for the south, for the west, for all the 4 directions. So this is a lot of code to achieve this. There's probably a way to do this a little bit easier, but this is probably the fastest way to do it. So that's of course always very important. And for me, more importantly, this was just the quick and dirty solution, and just because end portals are always the same, I will probably never have to look at this code ever again. And here we're also doing some of that get blocks at ID magic again. So this is just looking into like the cardinal direction that the player was facing in, and then placing the end portal frames in the right directions. Now stepping into an end portal works basically the same way as stepping into nether portal. We just check if the block that the player is in is an end portal block, and if it is, then we just go to the overworld if the player is currently in the end, or into the end if the player is not. And this again goes through the entity tick outcomes, but ultimately then lands again in the task queue, where then this task player use end portal then gets triggered. So this is a little bit simpler again compared to the nether portal, because if the player goes into the end, then they will always basically just land at x100, z0, and y49. We also check then if there is an obsidian block underneath the player, and if there is not, then we just place that like 5x5 obsidian platform. And yeah, that is basically it, right? We just place those blocks everywhere. Why does this exist twice? I'm not quite sure at the moment. Oh, right, we are also placing the air blocks, of course, so that just in case the end island is large enough to like cover that spawn position, then you of course don't want to spawn like in end blocks. You want to have this little chamber basically that you can then dig out of. Then we just call the change dimension functionality again. That is basically it. And if the player then goes back to the overworld, we're not using that new block position, and we're not doing all of this magic there. Instead, we just go to the default spawn location. So that is basically it with the end portals. Then there are also a lot of other changes that I've also added into this new version 0.8. One of them is, unloading chunks at some point, because for now I'm always just loading new chunks when the player is moving around, but then at some point, memory of the server would theoretically just kind of fill up if you have players just kind of wandering all over the place. So I'm now unloading chunks after a little while. For that, I've added a new keep loaded for ticks property to chunks, which originally is just 60 seconds, so 20 ticks in a second times 60, and then all the chunks will then just kind of get this number decreased by 1 every tick. But if a player is near a chunk, basically, then we just reset this keep loaded for ticks back to the 60 seconds. Now I know that vanilla Minecraft has this really neat ticket system where chunks get basically tickets for different things, and different ticket types mean different things, and different things get loaded, and it's a whole complicated system that probably has its merits, but for now I've decided to just go with the most basic possible implementation of this. Right, so if then the keep loaded for ticks reaches 0, then I am not doing any random ticks for that chunk. I'm not ticking the block entities in it. I'm not ticking the entities within it. Now at this point they're still in memory, so they're not getting ticked, so they're not causing any additional lag or anything like that. But as they're still in memory, they will still overfill memory theoretically at some point. So what I've decided to do was to just in my save to disk function then remove all the chunks that are not to be ticked anymore after I've saved them. The reason behind it is that then when I would want to unload a chunk, I am throwing it basically away. So all the changes made to the chunk since it has been last saved would then be gone. I could of course manually save the chunk before removing it, but because I always have to save not just a single chunk but a whole region at a time, that would be kind of a lot of overhead, and I'm trying to get rid of unnecessary overhead. So I've decided to just do it the most simple possible way. So once the chunk is saved, then I can safely remove it. And then there was also a kind of a leftover problem from the last video in which I've implemented farming. And that is that mobs didn't drop anything when they died. So to fix that, I've now added something to my my loot table code, where I now have a new function, get entity drops. And basically I'm just evaluating in the loot table. I had to do kind of a couple of changes and things here. I'm not going all over this like evaluating of loot table stuff again, but all I can say is that this part now works, and then this made it relatively easy to just, in the entity tick outcome processing, if the entity has died, then I can just get all the items to drop from that loot table function. I can then summon all the items that should be dropped. So this means now that if we summon a cow, we can kill it and it will drop some nice stuff on the ground. Yeah, maybe this is a little bit too much, but I will figure that out at some point. And yeah, that was basically now version 0.8.0, codenamed Waynesboro. There are of course many more little changes and things in here, which you can all find if you look into the link in the video description that takes you to the current release, if I put it in there, or if not, then there's also a link to the repository where you can also find that release. So now this new version basically just brings me a lot closer to that goal of being able to play through vanilla Minecraft completely. Because going to the nether end are of course, very, very important for that. But for now, these new dimensions and also the overworld are a little bit boring because there are no monsters really to fight. There's no mob spawning going on. So in the next version, I want to work a little bit more on that, have mobs spawn in places, and also have them maybe attack you and do a little bit of that stuff. So if you don't want to miss that, you should probably hit the subscribe button. And see ya then.